Can you solve this AP calculus problem? Let me know the answer in the comments below. Are you ready? Let's go. Okay, so we need to find the derivative of this expression x e to the power ln x squared. Okay, so first step is, if you remember, e to the power of ln x is going to be simply equal to x. Why? Because e to the power of x and ln of x, they are inverse functions, they will undo each other. Also, another way to look at it is log x base e is the definition of ln of x. And then if you write this in terms of an exponent, then e to the power of ln x is equal to this x. Okay, so in our case we have e to the power of ln x squared. So all of this is going to equal to x squared. All right, now remember also we have an x before we find the derivative. So x times x squared is x cubed, and we need to find the derivative of x cubed. So dx of x cubed, and we're going to use the power rule. So we're going to bring the 3 and bring it to the front. So that's going to be 3x 3 minus 1. Okay, so that's the power rule of derivatives. This is equal to 3x squared. So that is our final answer. In this case, it's choice C. Okay, is 3x squared. So let's look at it. What does it mean in terms? Let's take a look at the graphical explanation of this. So this is our original function right here, and that is represented by this graph. Okay, x e to the power of ln x squared, and it's going this way. Now, if you look here, the graph of the derivative of 3x squared is given by this parabolic graph. Okay, so you will see that here the slope is positive, but it's getting less steep. Okay, so the rate of change of slope is going to be negative, even though the slope is positive. So the derivative graph is above the x-axis, so it's positive, but its total slope is negative. You see this direction. Why? Because the rate of change of the uh, original graph is actually getting less steep. Now at 0, it's a horizontal line, so the derivative is also 0 right here. And then as the original graph is coming to this other side, it is getting more and more and more steep. Okay, so the rate of change of that is going to be a positive slope for the derivative graph. All right, hope you enjoyed this video. I'll talk to you in the next video. If you have any questions, let me know. I'll talk to you next video. Bye bye.